Hello.
Hello.
Yeah. Hi. So we'll continue with AMC problems discussion. Which papers have you tried? AMC
Uh,
2022, right?
yeah, we did that last time. I did the AMC 10 2023 this time.
10A or 10B?
I did 10A.
Okay. Okay. So let's discuss if there are any problems that you didn't get or anything that was difficult.
Yeah, the first one was problem 16.
Before that, 15 all were fine.
Yeah.
Okay. So problem 16.
Like I did some of it, but then I got stuck and I didn't really know what to do next.
Hmm. 1 second.
Yeah.
What is the question? Tell me.
Uh, in a table tennis tournament, every
Yeah,
participant, yeah, that
yeah, I
one.
got it. Uh, Fine. In a table tennis tournament, every participant played every other participant exactly once.
Yeah.
Problem 16. Every participant played every other participant exactly once. Exactly once. And then although there were twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the number of games won by right-handed players. Okay, so number of right-handed players is twice as many number of left-handed players, right?
Yeah.
And number of games won by left-handed is 40% more than number of games won by right-handed players. Okay, there were no ties and no ambidextrous players. There's no person who can play by both hands, and there are no ties. What is the total number of games? Okay, right. Fine. So if we say number of games won by right-handed players is R, number of games won by right-handed players is R, then number of games won by left-handed players is 1.4 R.
Right. Yeah.
Okay. So the total number of games must be 2.4 R, right?
Right. Yeah.
Total number of total number of games is 2.4 R, which is
Right.
basically 12 by 5 R.
Yeah.
Right. And every participant played every other participant exactly once. Right. So,
Right.
right. Um, what we have to find is, what do we have to find? Total number of games, right? Uh,
Yes.
Total number of games played. Uh, okay. 2.4 R. Total number of games is an integer. So If we have 12 by 5 x, then doesn't seem like any of the options are divisible by 5, right? No,
No.
there are. Some are
Yeah,
divisible by 5.
45 and 15.
Hmm. So, wait, we can say that total number of games will be NC2, right? If n players are there. We are choosing any two NC2, like any two combinations, no? So every participant played every other participant exactly once. So
Yeah,
out of n players, you can choose two in NC2 ways, right?
right.
So NC2 is total number of games. And out of these games, the ratio of games won by left-handed and right-handed is basically 1.4 is to 1, right? This is
Yeah,
left-handed wins and this is right-handed wins. So we can say that this is 7 by 5 is to 1. So that is roughly 7 is to 5 ratio, right?
yeah.
Okay, so why am I making it like this? Because now this tells us that uh, 7K and 5K, roughly like this, the total number of games will be, right?
Right.
7K games are won by left-handed people, 5K games are won by right-handed people, right?
Yeah.
That means total number of games is also 12K games,
Oh, so
right?
it's a multiple of 12.
So it's a multiple of 12, not like this. This is a little, see, this tells us that R is divisible by 5, right?
Yeah.
But we don't need to care about R. We need to care about total number of games played, right? R is
Right.
just the number of games won by right-handed people,
Yes.
which we now can see that it is 5K, which makes sense, right?
Yeah.
7K, 5K. These are the games won by left-handed and right-handed people, right?
Right. Yes.
So total number of games is 12K, so it is divisible by 12. So
Uh,
some of the options can be eliminated directly, right? How many answers are divisible by 12? Only two of them, 36 and 48, right?
yeah.
Correct. So now we also have to make sure that if it is 36, then K is 3, then can 36 be some NC2? We have to check which one is possible to be an NC2, right?
Yeah.
So we can do n into n minus 1 by 2. This is the meaning of NC2. That has to be equal to, okay, or we can also say it is equal to 12K, like this. So we can say n into n minus 1 is equal to 24K, right?
Yeah.
So notice that from the options we get the hint that either it is 36 or 48, right?
Yes.
So that means K is either 3 or 4, right?
Yeah.
If K is 3, we will get 72 here and n is equal to 9 fits that, right?
Yes.
But if K is 4, we will get 96, but there is no two consecutive numbers to give 96, right?
Correct. Yeah.
Do you understand what I'm saying?
Yes.
So from the two options itself, we can sort of realize that out of 36 and 48, n into n minus 1 should be 24K. We'll be getting a correct answer for 36, right?
Yeah.
That will be our answer,
Oh,
right?
okay. Yeah.
Another thing we could have done would be uh, Right, I think that's it. 96 is equal to n into n minus 1 has no solutions, but 72 is equal to n into n minus 1 has solutions, right?
Yeah.
Are you understanding?
Yes.
Okay, so that is 16th one. Then which one?
Number 17.
Okay. Uh, ABCD is a rectangle, that one, right?
Yeah.
Okay. ABCD is a rectangle. It is given that AB is 30, BC is 28. AB is 30, BC is 28. Point P and Q lie on BC and CD respectively. P and Q lie on BC and CD respectively, such that all the sides of triangle, okay, all sides of, so that all sides of triangle ABP, triangle PCQ and QDA, PCQ and triangle QDA have integer lengths. Okay. What is the perimeter of APQ? Perimeter of triangle APQ. Okay. So let's draw a figure and we make a rectangle 30 and 28. A, B, C, D, A, B, C, D. This is 30. This is 28. And the points P lies on BC and Q lies on CD. Okay, so let's say P is somewhere here, Q is somewhere here, and ABP, PCQ, and QDA. These triangles have all integer lengths, right?
Right.
So it doesn't seem very difficult because you can always say x and 28 minus x and things like that, no? We have to make sure that these are Pythagorean triplets, no?
Yeah.
So we can take BP as y and we can take AP as z, let's say, and we need Pythagorean triplets. This becomes 28 minus y. And so first of all, we have an equation y square plus 30 square is equal to z square, right?
Yeah.
Here. Then what can we say about this triangle? We have to take something about QD also. Uh, right. But before we do that, let's just focus on our ABP triangle first and figure out what we can do there. Uh, 30 square is coming out to be z square minus y square. So 30 square is equal to z square minus y square, which is z minus y into z plus y. And notice that this number is 900, but it is divisible by 4.
Ye-
we need to make sure that y and z are integers, right? Y and z are integers. So the left hand side of it is divisible by 4, right?
Yeah.
Correct. So the right hand side also has to be divisible by 4, right?
Right.
So think about it. That means that y and z have to be both even or both odd.
Right.
Why? Because if let's say one of them is even and one of them is odd, let's say, right?
Mhm.
If
Yeah.
that happens, then y plus z is also odd and y minus z is also odd.
Right.
That won't work, no?
Right. Yeah.
You need to make sure that that will definitely not work because right hand side is divisible by 4. But if both are even and both are odd, then the product of this will be even and even, right?
Yes.
Even or both are odd. These are the cases that will work, right?
Right.
Okay, so right now, what else can we say here? So let's look at some factors of this 900. So that is basically going to be 30 into 30 or 5 into 180, 50 into 18. Second, factors doesn't seem obvious. Way. Um, See, first of all, we know that y is less than 28, right?
Yeah.
We know that for sure. So we need to check Pythagorean triplets in such a way that something square plus 30 square is another square. That's what we need to figure out.
Yeah.
So in general, Pythagorean triplets can be made. We have seen that before also, I think. N square minus n square, 2mn, and n square plus n square, right?
Yeah.
Do you understand what I'm saying right now? These numbers will make Pythagorean triplets, right? Because sum of squares of these two first two will be the third square, right?
Yes.
Have you seen this characterization before of any Pythagorean triplets?
Yeah, 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 I remember. Yeah.
That's how you will make all any number of Pythagorean triplets, no? So,
Right.
our options are this 2mn could be 30 or 2mn could be or m square minus n square could be 30, right?
Yeah.
So, right, think about it. We have to make y and 30 from these two, right? And z has to be this one, right?
Right.
Correct. So
Correct.
think about it. M square minus n square is unlikely to be 30 because the squares are differing by more than 30 usually. Think about the squares, right? Of integers, right? When you look at the list of squares 4, 9, 16. 25. Right now the difference is not a lot, but soon the difference will become a lot. 49, 64, 81, 100, 121, then 144, 169. Now the difference is 25, right? 196. Now the difference is almost 30, 27 here, right? Then
Yeah.
225, 256. See, now the difference has exceeded 30, right?
Right.
225 and 256. After that, the differences are going to be bigger than 30, right?
Yeah.
So before that only we should get 30 somewhere, but I don't think any 30 difference is there, no?
Yeah.
Do you understand what I'm saying?
Yes.
M square by n square cannot be 30 then, right?
Right.
Do you get why I'm saying that?
Yes. Yes.
So this must be 30 then, right?
Right.
And this must be y, correct?
Correct.
So if this is 30, we get a sense of m and n. The product of m and n is 15, right?
Right.
So one way to do that would be 5 and 3, right?
Yeah.
And 15 and 1 also, but 15 and 1 will make it too big, right? N square minus n square.
Right.
Because then the side valence will be very big, right?
Right.
So 5 and 3, m and n fits that, right?
Yes.
So you will get here 25 minus 9, so 16, right?
Right.
Right.
Yeah.
5 and 3, and this side you'll get 25 plus 9, so 34, correct?
Right. Yeah.
So we are getting y is 16 and this is 34 then, no? Integer sides.
Yeah.
Do you understand how I have gotten 16 and 34?
Right.
Because I know that Pythagorean triplets can also be formed in this way. And I already know one of them is 30. So I use that to guess which one will be, what will be m and n. And from there I can make my other two numbers, right?
Yeah.
You can check that 16 square plus 30 square is 34 square. That's obvious.
Right.
256 plus 900 is 1156, which is 34 square, right?
Yeah.
So once we got this, now we get this 12, right?
Yeah.
And again, same logic you have to repeat because now we got one of it as 12 here, right? So we can
Yes.
take this as x and we need to find this also, right? So
Yeah.
12 square plus x square is this. So obviously now 12 is involved in very few triplets, 12, 5, and 13, I think, right?
Yeah.
So one option is this is 5 and this is 13, right? And if this is 5, this becomes 25, right?
Yes.
And this is anyway known as 28, right?
Yeah.
Correct? So
Correct.
25 and 28 square, you can calculate and find whether this is a Pythagorean triplet or not. Or you
Right.
can again do the same thing here, like use this characterization.
Uh-huh.
25 and 28 means 2mn is 28 then, right?
Yeah.
2mn cannot be 25, obviously, right?
Right.
So mn is 14. That means m and n are 7 and 2, right?
Right.
So notice that m square minus n square, 14, 7 and 2 doesn't seem to work. 1 second. Let's find the Pythagorean triplets for this one. If we know 25 and 28, we should be able to find it by the same characterization also. So,
Right. Yeah.
uh, 25, 28. So 2mn must be 28 and Mn must be 14. But Mn is equal to 14. 7 and 2 is coming. So something weird is happening. Although, like, we can just square it and check. 625 plus 28 square is, I think, 784, right?
I think so.
Yeah, it is 784. 784 plus 625. 1384 plus 25. So 1400 something. Let's check 28 square. 4, 16, 22, 0, 6, 1, 560. It is 784. 35 square. What is 35 square?
Isn't it like 1225? No, wait, no, that's like,
Right.
wait, it is 1225.
Oh, wait, we have made a silly mistake. That's why it is coming wrong. We have made a mistake. Oh, obviously we have made. That's why nothing is working out. This was 12. 12 and 5 and 13 doesn't work for us because this is 28, 25 and all is not a Pythagorean triplet. We are not getting a thing, no? Uh, you can see that I mean, this was also not working. No? 7 and 2 is not 25, no? M square minus n square, right?
Yeah.
So there is a problem with that. So let me just draw the thing again. So far what we have gotten so far is the correct triplet for this triangle, right? But we have not gotten the correct triplet here. We got this as 12, this is 16. This was how much? 30, right? And we got this as 34. We got the correct triplets here, right?
Right.
By the method that we did was m square minus n square, 2mn, and m square plus n square is a way to find triplets. And we said that 16 square, no, this was unknown. So we said unknown square plus 30 square is 34 square, right? Correct.
Yeah.
And we said that 2mn is 30, right?
Right.
From there, mn was 15. So m and n are 5 and 3, right? Correct. Do you understand how m and n became 5 and 3? And from there, we got m square minus n square as 16. So this became 30, and this became n square plus n square, which is 25 plus 9, 34, right?
Yeah.
Now, we still have to do this part. This also has to be an integer Pythagorean triplet. So 2mn is 12. 2mn is 12, then mn is 6, then 3 and 2 fits. So 9 minus 4, 5, right? So this side must be 5, and this side, okay, again we are getting the same thing.
Yeah.
So maybe we are choosing the wrong option. 2mn could have been the other one, and m square minus n square. Is it possible for m square minus n square to be 12? it could be possible that that one is 12, no, instead of 2mn being 12,
Yeah.
right?
Yeah.
So think of squares where the difference is 12. So 9, 16, 25, 36, 49. Wait, if this is 9, I know a Pythagorean triplet is 12, 9, and 15. 9 and 15. That is also a Pythagorean triplet. Basically, it's a multiple of 3, 4, and 5 multiplied by 3, right?
Right. Yeah.
This is a Pythagorean triplet. Obviously, there is another triplet which is what we were trying out earlier, 12, 5, and 13.
Yeah.
These are some triplets, but can we think of a way to get this directly? 12, 9, and 15. Uh, m square minus n square is 12, or 2mn is 12. These are our two options. There is no two squares which are differing by 12, no?
Uh,
9 and
I
16, and then 25, and then 36. 36 and 25 have a difference of 11. And after
yeah.
that, the difference becomes 13, right?
So no 12.
So no 12. So then how are we getting 12, 9, and 15? 2mn is 12, then mn is 6. Mn is 6, then m and n can be 6 and 1 also, or 2 and 3. Hmm. We have to think of how we can get that. Okay, maybe we can focus on the other one instead. If we are not directly getting this one, right now, let's assume that we have not figured it out. Okay. So we are not directly getting this length. So let's call it x. Then we know this one is 30 minus x, right?
Yeah.
And this one is 28, right?
Right.
So let's call it y for now. I don't want to use 30 minus x. So we have 28 square plus y square should be some unknown square z square, right? Correct.
Yeah.
So can we figure out that triplet directly? So 28 square will be z square minus y square will be equal to z plus y into z minus y is 28 square. Again, both have to be even and or odd. Both odd or both even, z and y, right? Correct?
Yeah.
Right. So um, If I use my characterization of 2mn is 28, I'm getting mn is 14 and 7 and 2. So 7 square minus 2 square, 45, and but that is too big.
Yeah.
So perhaps I should say that m square minus n square is 28. M square minus n square is 28. Then uh, the difference of two squares is 28. So we saw 169 and 196. The difference was 27. And after that, the difference was 29. Maybe something is wrong with my characterization. It doesn't work all the time. Hmm. If it doesn't work, then we'll have to test some small triplets. Like, I already know that 12, 9, and 15 works. I'm trying to get a way to get it without guessing.
Yeah.
12, 9, and 15 will work here, and then automatically after that, you should be able to get 21 here. If you know that this is 9, then this is 21. And 21 is 7 into 3, this is 7 into 4, though this is 7 into 5, right? 35.
Yeah.
So getting the answer is fine, but I wanted a better way to get it. The perimeter, the answer will be 35 plus 15 plus 34, right? It is 84.
Right.
That's the answer. So basically, this thing is failing when, or I'm not getting the direct answer when it is a multiple of a smaller triplet, right? Like for example, here if you see 12, 9, and 15 is a multiple of 3, 4, 5, right?
Yes.
Similarly, when you come here, 28, 21, and 35 is also a multiple of 3, 4, 5 with 7.
Yeah.
So keep that in mind that sometimes from smaller triplets, you can multiply k times 3 and k times 4 and you'll get a k times 5. That is a bigger triplet, right?
Yeah.
Hmm. Uh, this helped us get the first triplet, but after that, we are facing some issues in getting the other triplets from the same method, right?
Right.
I'll think about if there is a better way, but right now we can get the answer because we are able to guess. There are only few triplets where 12 will be involved. It's not like 12 has many other options. If we tried 12, 5, and 13, it was not working out, right?
Yeah.
So you can't really use 12 in any other triplet. These are, I think, the only two triplets. 144, 81, and 225. 144, 25, and 169, right?
Yeah.
So
Right.
we have gotten the answer, but like I'll think about it a little more and let you know if there is something else that we can do here.
Okay.
Uh, let's go to the next problem for now.
The next question I had was problem 19.
Okay. Uh, right. The line segment, that one, right? The question says the line segment formed by A and B, that right?
Yeah.
Line segment formed by A, which is 1 comma 2, and B, which is 3 comma 3, is rotated to the line segment, is rotated to the line segment formed by A dash and B dash about the point Rn, okay? Formed by A dash, which is 3 comma 1, and B dash, which is 4 comma 3, about the point P, R comma S, about the point P, which is R comma S. What is mod of R minus S? So there is a line segment from 1 comma 2, 1 comma 2, which is my A, to this is 1 comma 2. Let's mark it a little better. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1 comma 2 is here. This is my A. And 3 comma 3 is here, right? This is my B. This is my line segment, initial line segment,
Right.
which is rotated to form a new line segment from A dash 3 comma 1 to B dash 4 comma 3. 4 comma 3 is somewhere here, right?
Yeah.
So it is rotated about a point, unknown point, to get to this shape, this way, right? Correct.
Yeah.
So we have to find that unknown point, or at least the difference between the x and y coordinates of it.
Yeah.
So basically we have to find the center of the rotation,
Right.
right? So also remember that in any rotation, the distance is not changed of any line segment, right? The length.
Yeah.
So from distance formula, we can say that, like, imagine it was rotated through some center. Like, I don't know what the center is. It seems like it will be somewhere here or something, right?
Yeah.
But I don't know what it is, so I'll put a random point somewhere here. This is my center of rotation, right?
Right.
And looking from there, you are turning the line and making it like this, right? Something, right?
Yeah.
This is my R comma S point, right?
Right.
So because it's a rotation, the distance cannot be changed in any rotation, right? So we
Yes.
can say distance of A from point P should be same as distance of A dash from point P, right?
Yeah.
Correct. And similarly, you can say distance of B from point P should be same as distance of B dash from point P, right?
Yes.
Because that's how rotation works. If you take a line segment and rotate it about some origin, let's say, then
Mm-hmm.
automatically the new points that it will be, the distance of this from the origin is same as the distance of this from the origin, right?
Yeah.
That's what it is, the meaning of a rotation.
Right.
So if you do that, we can just use distance formula now because point P is r comma s, and we can write distance. All of these ones were given, right?
Yeah.
So we can say A to P, the distance is r minus 1 whole square plus s minus 2 whole square. Square root of that, which we have squared, so distance squared, is equal to, on the other side, A dash to P, so r minus 3 whole square plus s minus 1 whole square, right?
Yeah.
And bringing all the r's on one side here, you'll get r minus 1 square minus r minus 3 square is equal to s minus 1 square minus s minus 2 square, right?
Right.
So this will become a plus b into a minus b. So 2r minus 4 multiplied by the difference is 2 is equal to 2s minus 3 multiplied by the difference is 1, right?
Yeah.
So one equation we are getting is uh, 4r minus 8 is equal to 2s minus 3, right?
Right.
Okay. Uh, and the second equation, okay, let's keep it here right now. And the second equation from here is coming out to be distance of B from P. So r minus 3 whole square plus s minus 3 whole square is equal to B dash from P. So r minus 4 whole square plus s minus 3 whole square, right?
Yeah.
Okay. R minus 4 whole square. Right. So this s minus 3 whole square is getting cancelled, and we are getting r minus 3 whole square is equal to r minus 4 whole square. So r is 3.5 obviously from here, right? Do you understand why r is 3.5?
Yeah.
There is no other way. Like you, when you equate it, you will have to say that r minus 3 is equal to 4 minus r, right?
Right.
So when you automatically get r is equal to 3.5, 4r is equal to 14. And from the first equation here, 14 minus 8, 6 plus 3, 9 by 2. So S is 4.5, right?
Yeah.
So R and S are 3.5 and 4.5 and mod 1. This is 1, right?
Right. Yes.
So we have done nothing. We have just noted that in any rotation, the distances cannot change. Distances from where? From the center of rotation, right?
Yeah.
So that is what we directly applied.
Oh, okay. Yeah.
So there's nothing we did here, just distance from the center of rotation of a point cannot change because that point has just been turned to some other place, right?
Yeah.
So keep this in mind, it's an important idea. The other way to do this would be to try to find the point directly. So again, we would have to use the same concept, but then you can also notice that if BP is equal to B dash P, the same thing that we did here, as well as AP is equal to A dash P, right?
Yes.
Then P must be, think about it, BP is equal to B dash P. Let's say P is somewhere here. BP is equal to B dash P and AP is equal to A dash P. Then AP is equal to A dash P. Then uh, I think there will be some P should lie on the perpendicular bisector of A. One second. If you see, if you join A dash and B dash, if you draw a perpendicular bisector of A dash, right? Okay, now I get it. Okay. So another way to do the problem would be like this. Let's say this is my AB, and let's say this was my A dash B dash, right? I don't need to worry about the exact orientation and stuff, right? Right. So
Yeah.
I know there is some center of rotation somewhere, right?
Right.
And that point is, let's say, some P. What I know is AP is equal to A dash P, right?
Yes.
So P is equidistant from A and A dash, right?
Right.
What do you think? Where do you think P should lie from A and A dash? Anytime you have a point which is equidistant from two given points, that point lies on the perpendicular bisector of the two points. Do you understand what I'm saying?
Oh, yeah, 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 right.
Anytime you say that some point x is equidistant from two given points, the x should lie on the perpendicular bisector of AB, right?
Yes.
By congruent triangles and all, right? So we
Right.
know P lies on perpendicular bisector of A and A dash, right? Correct.
Correct.
Similarly, because it is B and B dash are also equidistant, so P lies on perpendicular bisector of B and B dash, right?
Right.
Because BP is equal to B dash P also, right?
Yes.
Correct. So P, like if you can figure out the perpendicular bisector here and the perpendicular bisector here, P is the point of intersection of those two lines, right?
Yeah.
So now think about it. A dash and all were all given to you. So you can actually find P directly, you know.
Right.
So
Oh,
A
yeah.
and A dash were given to you. So let's see. I mean, we have already found P by distance formula. It's not like that difficult, but this is a different way without using distance formula, right?
Yeah.
So A is 1 comma 2, A dash is 3 comma 1. 1 comma 2, A dash is 3 comma 1. So the midpoint is what? Midpoint is 2 comma 1.5, right?
Yeah.
And the perpendicular line to it, we also have to make it perpendicular bisector. So some line like this. So slope of this we know, right?
Right.
Slope of this is 2 minus 1 by 1 minus 3, right? Gradient of A dash, right?
Yeah.
So that is minus 1 by 2, right?
Right.
So the slope of our line should be plus 2, right?
Yes.
Do you know this stuff? That
Yeah, yeah.
perpendicular. Okay. So our line should be having slope plus 2 and it should pass through this point, right?
Right.
So our line equation will be y minus 3 by 2, which is 1.5, is equal to 2 into x minus 2, right?
Yeah.
So basically our line equation we have gotten y is equal to 2x minus 4 plus 3 by 2. So minus 8 by 2 plus 3 by 2. So minus 5 by 2, right?
Yes.
This is my line equation for this perpendicular bisector. Similarly, I'll find this perpendicular bisector also. So B dash is what? B dash was, uh, one second, 4 comma 3 and B was 3 comma 3. Okay. So 3 comma 3 and 4 comma 3. So midpoint is 7 by 2 comma 3, right?
Yeah.
Midpoint is 7 by 2 comma 3. notice that the slope of this line is 0. y2 minus y1 by x2 minus x1, right?
Yes.
Slope of this line is 0, so it's a horizontal line. So perpendicular to that would have slope infinity, right?
Yeah.
So the equation of this perpendicular would be simply x is equal to 7 by 2, right?
Right.
Do you understand? This is a horizontal line, although my figure is not showing that, right?
Yes.
So perpendicular bisector would be simply x is equal to 7 by 2. Now you have to intersect this line, this perpendicular bisector with this, right?
Right.
If you put x is equal to 7 by 2 here, you get y is equal to 7 minus 5 by 2, which is clearly 49 by 2, 4.5, right? So we are getting the same answer, 3.5 comma 4.5 is this point, right? X is 3.5, y is 4.5, right?
Yeah.
Do you understand what I'm saying?
Yes. Yes.
So you should remember that whenever a point is equidistant from 2 points, it lies on the perpendicular bisector, and we can use a little bit of coordinate geometry and find equations of those two lines and intersect them also. Or you can use the distance formula method that we did earlier, right?
Right.
Okay. Next, tell me which one.
Uh, it was problem nine. Oh, that was 1921.
Okay, fine. So problem 21. Px is a unique polynomial with of minimal degree with the following properties. They have given leading coefficient is 1. Leading coefficient is 1. 1 is a root of px minus 1. Px minus 1 has root 1. 2 is a root of p of x minus 2. P of x minus 2 has root 2. 3 is a root of p of 3x. Root of 3. And finally, 4 times of px has a root 4, right? Has a root 4. Okay. The roots of px are integers with one exception. Roots of px are integers with one exception, and that exception, that root can be written as m by n. That other non-integer root is m by n. We have to find m plus n, right? Correct, no? So think about it. Do you understand the problem? What is the problem? Hello?
Oh, sorry, I was on mute. So it's like you have a function px, and then px like moved
Hmm.
one down has a root of 1. Px moved to like the right 2 has a root of 2.
Right.
Px like yes, so on and so on.
So usually if somebody says px has root a, you can say it's a polynomial. You can say x minus a is a factor, right, of the polynomial.
Yeah.
This is known as factor theorem. You should know that. Like for example, in any quadratic, if you say roots are 3 and 4, the quadratic will be x minus 3 into x minus 4.
Right. Yeah.
So as long as the leading coefficient is 1, because we usually you have to worry about that leading coefficient a times that, right?
Yes.
So this is like a quadratic with leading coefficient a. But here the leading coefficient is 1. So anyway, the px polynomial will look like something like this: x minus root 1 times x minus root 2 times x minus root 3 and so on, right?
Yeah.
If you multiply it out, you will get your polynomial, right?
Right.
So now what can we know from all this stuff, all of this information, right? That is what we have to write down, okay? So when you say p of x minus 1 has root 1, that means if you put 1 into this, it will be 0, right?
Yeah.
Do you understand what I'm saying?
Yes.
So you should be able to say that p, put 1 into this expression. So p of 1 minus 1 should be 0, right?
Yes.
So that gives us p of 1 is 1, right?
Right.
If you put 2 into this expression, it should be 0, right?
Yes.
That's why this expression has root 2, right? So that gives
Yes.
us p of 2 minus 2 is 0, which implies that p of 0 is 0, right?
Right.
Similarly, from here, we get that p of 9 is 0, right?
Right.
And from here, what do we get? 4 times p of 4 is 0.
Uh-huh.
So automatically right now, we know that, look at p of x. We already know that 0, 9 and 4 are roots. Can you see that?
Yes.
So that means automatically x minus 0, x minus 9, x minus 4 are factors,
Yeah.
right?
Right.
So now we might have one more root. They have said that the roots of px are integers with one exception, right? Already three roots we already have: 0, 9 and 4. They are all integers, right?
Yes.
The last root has to be a rational number m by n, right?
Yes.
And we have to make px as a polynomial of minimal degree. We want to keep the degree of the polynomial as low as possible, right? We
Right.
already know three roots, so it has to be a cubic, but there has to be one more root, so it has to be fourth degree polynomial, right?
Yeah.
If you want to keep the degree as low as possible, you have to keep 4 degrees, right?
Right.
You cannot go to 5 and all. It will make it higher degree than necessary, right?
Right.
So three roots in teachers, one root unknown. Let's say that unknown root is a, or a should be m by n. So I'll keep it as a for now. So what I will say is my polynomial will be x minus 0 times x minus 4 times x minus 9 times x minus a, right?
Yeah.
This is the minimal degree polynomial, correct?
Correct.
But remember, we have not used the first condition so far, which was p of 1 is 1.
Right.
That did not give us a root. The other conditions gave us roots, right?
Yeah.
So now I'll put that here. So 1 is equal to, when I put 1 in this, I get 1, 1 minus 4, 1 minus 9, 1 minus a. And I will get 1 is equal to minus 3 minus 8. This becomes 24, 1 minus a. So you get 1 by 24 is 1 minus a. So a is equal to 1 minus 1 by 24, right? So 23 by 24, right?
Yes.
So notice that the fourth root is coming out as a rational number m by n, and these are not having any common factors. So 23 by 24, so m plus n is 47, right?
Yes.
So the point here to remember is, in polynomials, when you know the roots or you want to characterize the roots, you should always remember that any polynomial, even if it looks like this, an x bar n plus an minus 1 x bar n minus 1, and so on till a0. This is a general polynomial. If it has roots, we can write it always as an, the first leading coefficient, times x minus root 1, x minus root 2, till x minus root n, right?
Right.
Because every time there is a root, there is a corresponding factor, right?
Right.
And a degree n polynomial will have automatically up to n roots. It has to have n roots. However, many times what happens is the roots are real. Some of them are real, some of them are imaginary or complex numbers,
Right.
right? In this problem, we wanted to make a polynomial with minimal number of minimal degree. And from the data given in the question, we already can see that P of 0 is 0, P of 4 is 0, P of 9 is 0 and all, right?
Yeah.
So we already got three roots. So fourth root was a non-integer. So that's what we put it as this. And the question had already said that leading coefficient was 1. So an is 1, right?
Right.
Are you understanding?
Yes.
Okay. Fine. So remaining problems here, we can finish in the next class. And you should try, which other paper is left? Is there any paper left?
Yeah, I think there's one more. It's probably the 2024 one.
So try uh, that one paper that is left, 2024 one. We have not done 2023, right? We didn't get 2023 paper, right?
This one was 2023A, and then we have to do 2023B.
Okay, so then 2023 B and 2024, whichever paper you have.
Okay.
These two try in this week, and if you are done with them, I will send more papers, but just try these two papers at least.
Okay.
Yeah. Next class will be number theory. We'll continue from where we left off. We were doing Euclid's division lemma and problems on that and all, right?
Yeah.
So we'll continue the theory there. And yeah, that's about it for now. But definitely try two papers. You have to try 2, 3 papers per week. Then only you'll get the hang of it. Okay.
Yeah. Okay.
So the exams will be in a few months. So it will be in which month of the year?
November. Like early November.
Right. So if you do 2, 3 papers per week, then you will be well prepared by that time.
Okay. Yeah.
Because there are many things to learn. Like one part of our class, we are doing number theory. So we will finish number theory maybe in a month or so. After that, we'll go to other topics, or not a month, maybe 2 months we'll take.
Okay.
But after that, we'll go to other topics as well, which will cover any gaps in theory. But we will get to know those gaps only if you do papers.
Right.
So doing the papers is absolute must, and at least 2 papers per week you have to try. Okay.
Right.
So try these two, and if required, we'll take some extra time and try to finish all the doubts and all whatever is required. Okay,
Okay.
fine. That's all for now then.
All right. Thank you.
Bye.
Bye.